All right, so here's the problem. Now pause and try and solve it. Okay, so fairly straightforward, I think. Not too difficult of a problem, but I like this because it does kind of help to illustrate the conceptual idea of the Doppler effect. So the Doppler effect, remember, is the effect that results from when you listen to a sound while the sound is moving relative to you, right? So keep in mind, this is always relative to the observer, right? The observer and the source of the sound, right? So what that means is that as long as there's a velocity relative to you, then it doesn't make a difference. So for example, if I'm on a train and I'm listening to music coming from a speaker that's also on the train, there's not going to be any kind of Doppler effect, right? Because the speaker is not moving relative to me. We may be both moving very quickly, but it's not moving relative to me, right? And so that's all really that matters, whether the thing has a velocity relative to yourself. So for all of these, let's take a look and see if there is a relative velocity happening from the source or the observer, right? So a car moves toward a stationary observer while honking its horn. So yeah, so let's say you're the observer and a car is coming toward you, honking its horn. The car's moving relative to you. So there is a relative velocity happening there, right? A person jogs away from a stationary speaker playing a steady tone. In this case, of course, the person listening is moving and has a velocity. And the stationary speaker is not moving, but again, the same thing. There is a relative velocity happening between the observer and the source of the sound. And then C, a fire truck passes moving traffic on the highway. And so, yeah, the fact that the fire truck is passing traffic means that the fire truck is moving relative to the traffic, right? And so that would have an observed shift in frequency. And then finally, D, sound source and an observer move at the same speed in the same direction. So only in this case, only in case D, would there not be an observed shift in frequency. They wouldn't be subject to the Doppler effect because they're moving at the same speed in the same direction, meaning that that there is no velocity between the source and the observer. So no relative velocity here. And again, the analogy is like if the source and the observer are both on a train, and the train may be moving very quickly, but you can't, there's no Doppler effect happening there, right? It requires them to be moving at different speeds, or there to be a velocity difference between them. And so the correct answer here is going to be D. D is the only scenario where we don't have the Doppler effect, meaning that we don't have an observed shift in frequency.